Newton's first law, also referred to as the law of inertia, states that a body at rest tends to stay at rest, and one in motion will tend to stay in motion. Inertia is similarly defined as a tendency for any object to resist change in its state of motion. To demonstrate the property of inertia, a heavy iron ball is suspended by a thin string with a second length of string attached to the bottom of the ball. The amount of inertia which an object has is determined solely by its mass. The more mass, and therefore the more inertia an object has, the harder it is to change its state of motion. By applying a force to the bottom length of string in two different ways, interesting results can be obtained which illustrate this property of inertia. If the bottom string is pulled with a slow, steadily increasing force, the upper length of string is observed to break as a result. If a quick, sharply applied force is given to the bottom string, the bottom length of string breaks, leaving the upper length unaffected. To explain these results, let us consider the forces acting during the first trial. Before the force is applied, the upper length of string is initially under a tension equal to the weight of the iron ball, whereas the lower string is under no tension at all. As the gradually increasing force is applied to the lower string, the tension on every element of the suspended system increases by the same amount. Since the tension on the upper string is equal to the weight of the ball plus the applied force, it experiences a greater force than the bottom string and thus breaks first. During the second trial, the sharply applied force appeared to have no effect on the upper length of string. This can be explained in terms of the ball's inertia. The ball, being of relatively large mass and large inertia, has a strong tendency to resist any change in its motion and tends to remain in its original state of rest. As a result, the rapidly applied force does not cause the ball to move or accelerate by any appreciable amount, and the force is not transmitted to the upper string. Instead, the force is felt fully by the lower string, which consequently breaks.